Cool. All right. Thanks, everyone, for jumping on and joining. Um, and really appreciate the Pyth guys for reaching out to invite us to do this keynote. I guess the key topic here really is just talk about zkSync and the plans we have for 2024 and how we plan to basically improve our ecosystem to then improve kind of like the greater crypto ecosystem, as well as the environment for our ecosystem of partners. I guess to kick off on some context, so I'm Bayo Akins. I look after infrastructure on the BD side, which means I lead kind of our relationships with the main infrastructure partners in our ecosystem. So that includes Oracle partners like Pyth, but then RPC partners, data partners, exchanges, wallets, etc. in our ecosystem. Prior to this, I was at Coinbase for a period in the cloud team, and then prior to that was at Elliptic, the crypto compliance company, as well. So happy to share a bit more about zkSync in particular. Happy to just evolve and use some of the insights that I have from a couple of years in the industry. I guess to jump in, zkSync is a Ethereum layer 2, and we use zero knowledge to scale Ethereum. I guess for us, a couple of years ago, we made a number of design decisions as a team. And I think now is actually the perfect time that we're able to lean into those decisions and benefit because of them over the next year or so. So that is how our zk stack infrastructure is being set up. The decision to use native account abstraction, whilst Ethereum was working out 433C as a kind of abstraction, or 4337 as a kind of abstraction on chain, using state differences instead of core data. There's a couple of different things that we've done, but now we really get to benefit from how we go from there. And our vision really is to ensure that crypto becomes adopted in a mainstream way, which allows people to make their own decisions. And we think the control of your finances is closely linked to really self-sovereignty and freedom as in general. I think it's quite obvious, at least in the Ethereum ecosystem, that although there's a lot of activity, there's a lot of TVL, there's a lot of people interested in ETH in more general. I guess one of the big issues for Ethereum as a protocol is the scaling issue. So truly the blockchain trilemma being decentralization, security, and scalability. When bull markets or times get better and there's more activity on chain, the cost of interacting with Ethereum, especially on the gas side, becomes quite expensive. And so really for Ethereum as an ecosystem to truly scale, we need kind of to address that. Hence where zkSync falls into that. Again, our purpose really is to break the financial barriers and enhance the world's freedom. And really, we believe that you do that through accelerating the mass adoption of these blockchains. In simple terms, as a layer 2, what we do is we take a number of the activity that happens on chain. We compress those activity together. Then we create a proof. We then send that proof down to Ethereum. And so what that means is that the cost of an individual transaction is being split through many different activities on the blockchain or many different transactions. And so subsequently, those transactions are cheaper for those who are interacting with the L2 or then with the technology, the L3 in that case. So far, we launched zkSync Era in March 2023. We have to date about 530 mil TVL. We're doing about 30 million transactions per month, and there's about 250K daily active addresses. And so there's quite a lot of activity on chain, which is one great proving for us in terms of how the infrastructure is able to stand up. But it's also amazing as we continue to develop our ecosystem And we have a number of exciting projects and advancements that are coming into the ecosystem in the very near future. So a big part of that is zkStack. So zkStack is our new app chain ecosystem, but fundamentally it's a developer-friendly modular framework that basically makes it easy for users or teams to customize and deploy their own interoperable zk-powered blockchains. So the vision here is to enable companies, developers, etc., to build their own app chains in a way that they are able to use our infrastructure, like what we've built with zkSync Era, but also in the benefit that everything is somewhat interconnected to all the app chains that get launched with zkStack. So in simple terms, there's two key components to this. There's the hyperchains themselves. So these are the L2s or L3s that get launched, zkSync Era being the first hyperchain. And then the second part of that are the hyperbridges. So that hyperchains themselves, they have basically share a shared, or as you can see through the image, I'm not sure if you can see my mouse, so let me not try in case you can't. They share a bridge contract on the L1 on Ethereum. The hyperbridges are native bridges in our ecosystem, connecting all the different hyperchains. And these native bridges can allow for minting and burning natively, which allows transfers between these hyperchains. In simple terms, that means that the original assets are locked in the L1 bridge contract, but the liquidity is unified across the ecosystem. So unlike other app chain ecosystems, which launching a new L2 or launching a new L3 starts to fragment liquidity, all our liquidity sits within the bridge contract, but is shared with the wider ecosystem. So every new chain that deploys into zkSync or the zkSync network of hyperchains just adds to that hyperchain and isn't reductive in that sense. So this allows for the settlement on the hyperchains to go down to minutes or be super fast, but each chain starts to connect. So the concept for hyperchains is like hyperlinking, where you're able to click a hyperlink and go from site to site. We want that same shared experience within our hyperchains. But the benefit of hyperchains themselves is that with our stack, you're able to choose your setup. So there might be a use case for an NFT marketplace on one side. There might be use cases for financial institutions and their products, might be exchange products, derivative projects, a whole bunch that users want to build and interact with their own app chains. But they might have different expectations around how data availability should work, whether it should be public or private, what the sequencing looks like. And we, as an infrastructure provider, don't want to inhibit that. We want the innovation to go purely to the ecosystem, and then the hyperchains themselves to be spin up and be native to whatever the use case is. So, for example, if we look at this is kind of like an example for a financial institution. They might need, for compliance reasons, a privacy focused chain with centralized sequencing. They need it to be performant, more importantly than EVM equivalents, and they want it to be a Validium. You can do that, launch the app chain, and that just joins the wider app chain ecosystem. So that benefits from liquidity where possible from zkSync Era, and that benefits from all the users in and around the ecosystem in that sense. I guess from that, what that then starts to do, like I said, is it allows users to then have kind of like a simpler experience interacting with the hyperchains. So really, it's kind of like if there was a DEX hyperchain and you wanted to make a transaction, rather than having to go to the DEX and connect your wallet and a whole bunch, you'd be able to just click and send transaction to this hyperchain. And then with that ecosystem, that then compounds. And to some degree, the experience isn't a crypto native experience. is more like a web experience that users can expect to be using in the L2. So a key component of the zk stack piece in general, or our ecosystem as we designed to build it, is this aspect of native account abstraction. So I don't only necessarily overlabor the concept of account abstraction, because I personally think the phrase is a bit complicated, and really we need to abstract away the complexity in the blockchain. But the concept here is that if we really want blockchains to scale, we need interacting with them to be as simple as possible. So you don't need to know the details and the nuances of how they interact. I personally don't know how my FaceTime works on my iPhone, but I know that if I go to it and I click my mum's number, FaceTime works. And that's the experience I suppose crypto needs to get to if we really want to scale in that sense. So as we develop our ecosystem, we have taken the decision again a couple of years ago to use native account abstraction. So there's no kind of like third parties in between. There's no risk, and there's no extra expenses that go into that. And so we're able to have one of the cheapest experiences for account abstraction within the ecosystem. So that enables us or users to do things like social recovery. That enables users to set their own transaction rules and parameters. So for example, if you're playing an online game, you might want to say that, okay, for this hour, I just want to have auto accepting of transactions, which doesn't stop the gameplay, but no transaction should be above X cost, or once it hits this limit, then prompt me in that sense. We can now start to set the rules for a native experience that makes a bit more sense to how users expect to interact with the internet in general. Then we can start to decouple the idea of seed phrases and such. And so you can start to sign into transactions with your Face ID, with your thumb. You can start to send transactions, accept transactions using these methods as well. And then obviously create all of these different session keys. But really, account abstraction allows us to scale crypto in a way that makes a lot more sense for users in that regards. The next key piece of that, especially importantly when it comes to scaling Ethereum, is fees. So I was in transactions today, and obviously with everything going on, fees on Ethereum had gone up. But the beauty for us is that last night we launched Bujin. So Bujin is the new Stark-based proof system. This is on our journey to try and get transactions down to fractions of cents. And with that, we've now become the cheapest L2, even cheaper than the optimistic rollups, which have historically had kind of like a technical advantage. And we're still doing a number of optimizations to start to get these transactions down even lower, like I said, to the fractions of the cents. But fundamentally, unlike any other proof system that occurs, we've kind of taken away the way in which proofs are generated, as well as how the proof system needs to be upgraded so it doesn't interrupt any protocol liveliness. So we don't have to go down as an ecosystem to allow these upgrades. And so really our sequencer right now can process over 100 transactions per second, and the proof system can work on more native or can work on kind of like hardware which can be or unsophisticated hardware which can be held in a house. This really helps on our mission for decentralization as well. And so we're looking at 16 gigabytes of RAM, and so really we have ironically optimistic view on what we can then go to do in the ecosystem in the future. I guess another piece of the fees is the decision that we made to publish only state differences and not the core data. So state differences is basically the difference in the state at the beginning of the block and at the end of the block. And so what this does is this allows for efficiency in chain. So we only publish the final state changes. So if I send a transaction to person A sends a transaction to person B, rather than publishing all those transactions, what we will publish is what the addresses have looked like after all those transactions have been made in that block. So what that does is that saves space, and that space saves resources. And so from a data availability side, it means that we can verify the state on the L2, even though the state will also be available on the L1. In terms of cost effectiveness, of course, it's more economical because we're publishing less data to Ethereum in that sense. And then we're also leveraging the state difference for a number of use cases. So one of the use cases obviously relevant to Pyth is oracles. If oracles are able to provide more prices at the same or less cost, then what they can do is start to provide more prices on chain. So for example, if we have a block a minute, and in that minute, you're able to publish a price every second, then there's more stable prices. But because it's in the same block, you're only paying once for that, because it's really the state difference in this regards. So the benefits are oracles can provide more prices at cheaper, if not the same price, which allows the products built leveraging oracles to be more sturdy in that sense. And then there's a total knock-on effect for the ecosystem in that regards. The next piece is kind of like there's the less data, means there's the lower cost, of course. And so we can have more use cases, especially for privacy preserving applications on chain. And then from the trading perspective, the DEXs and the perpetual traders benefit because there's the same slots to update transactions. And so they can batch transactions in together with no extra cost. So fundamentally, anything that requires the repetitive storage slots, developers can optimize the transaction batching to reduce these fees. So you can strategically group transactions together, and so they can maximize the benefits in that regards. And so there's a number of things that you can do there. I guess, again, to wrap up, the key things that we are building and pushing for in 2024 is the zk stack and the infrastructure that allows users to launch their own app chains in our ecosystem with the shared liquidity. The second is account abstraction and how interacting with apps in the era or the zkSync ecosystem are going to be more native to how we interact today with the internet. And then thirdly is more benefits in regards to the decision to do state diffs to make things cheaper and useful in that sense. So yeah, so that is zkSync in a nutshell. And yeah, really appreciate everyone in this case for taking the time to jump on and stay up to one of the latest conversations. And then yeah, I guess happy to answer a couple of questions if they appear in the chat. Okay, Jay, so he said, what about risk zk has from quantum hacks? What would you do to mitigate that? I think the quantum hacks or quantum computing in general is definitely something that is interesting for the wider ecosystem. So that's beyond zkSync, that's beyond crypto in general. It changes the paradigm for how the internet works in that sense. I guess there's some research pieces that we're doing at the moment, but it really depends on the timeline for quantum computing and how quickly that, I suppose, gets adopted more widely, and upgrading as necessary to those threats. Cool. Thanks, guys. Really appreciate you taking the time, and thanks for jumping on.